Since the dawn of humanity, we've gazed at the sky, searching for meaning in the patterns above. Our ancestors noticed the sun's daily journey, rising, arcing and setting, repeating with unwavering regularity. This rhythm became humanity's first clock, a promise that light would always follow darkness. The moon too revealed its own cycle, waxing, waning and governing the tides. These patterns weren't random, they hinted at a deeper order. The seasons brought their own dependable changes. Spring's renewal, summer's growth, autumn's harvest, and winter's rest. Life, rituals, and survival depended on reading these cycles. Recognizing patterns was our first step toward science, a simple act of paying attention. By observing, we realized the universe had a rhythm, a pulse, and rules that everything seemed to follow. This understanding that the world was knowable sparked our journey of inquiry. It was the foundation for all future discovery. The universe, once mysterious, became a tapestry of recurring events. Our curiosity about these rhythms set us on a path we still walk today. The search for order in nature is the story of science itself. What is a law of nature? In science, it's not a command, but a description, a concise statement of a pattern we see in the universe. Scientific laws capture how things behave based on repeated observation and testing. Take the planets. For centuries, astronomers noticed their movements weren't random. Kepler's laws described their elliptical orbits and changing speeds, summarizing a cosmic order. Or consider the law of conservation of energy. Energy can't be created or destroyed, only transformed. The sun's light, the food we eat, the warmth we feel, all are forms of energy, shifting but never vanishing. These laws don't force nature to behave, they simply describe what always happens. Laws are the bedrock of science, verified so thoroughly we trust them as fundamental truths. Unlike theories which explain why, laws tell us what to expect. They're the simple, elegant rules behind the universe's complexity. When we speak of a law of nature, we're describing the universe's most reliable patterns. These laws let us predict, build, and explore with confidence. They are the language of the cosmos. Gravity is perhaps the most familiar law of all. It's the invisible force that keeps us grounded and shapes the cosmos. Drop an apple. It falls every time. That's gravity in action. But gravity's reach is vast. It formed stars, planets and galaxies from clouds of dust and gas. It holds Earth in orbit, gives us seasons and binds the Milky Way together. Without gravity, the universe would be a cold, scattered soup. Newton's law of universal gravitation unified the heavens and earth with a single equation. Every object attracts every other, with a force tied to their masses and distance. This law explained both falling apples and orbiting moons. Einstein later reimagined gravity as the curvature of space-time, massive objects bending the fabric of reality itself. This deeper view made even more accurate predictions, especially in extreme conditions. Whether as a force or a curve, gravity is the unseen architect of the universe. It sculpts worlds, choreographs galaxies, and shapes our very existence. The law of gravity connects the everyday to the cosmic. It's a constant companion, guiding the dance of the cosmos. How do we discover nature's laws? Through the scientific method, a process of curiosity, observation and testing. It starts with noticing a pattern or mystery in the world. Scientists form hypotheses, testable explanations for what they see. They design experiments controlling variables to isolate the truth. Results are repeated and verified by others, ensuring reliability. If a hypothesis survives rigorous testing, it may become a scientific law, a trusted description of how the universe works. This journey from observation to law is built on persistence and collaboration. Each law is a testament to our drive to understand the world. Science advances one careful experiment at a time. Are the laws of nature the same everywhere in the universe? Evidence says yes. When we observe distant galaxies, the light we see carries the fingerprints of the same physical laws we know on Earth. Spectral lines from elements like hydrogen and helium match perfectly, even across billions of light years. The constants of nature, like the charge of an electron, appear unchanged across space and time. This universality lets us study stars, measure cosmic expansion, and piece together the universe's history. If the laws varied, the cosmos would be chaos, not order. Instead, we find a universe governed by the same rules, everywhere and everywhen. This consistency is what makes science possible on a cosmic scale. The laws we discover here apply across the universe. Could the laws of nature change over time? Some theories suggest the universe's rules might have shifted in its earliest moments. Scientists search for tiny changes in fundamental constants, comparing ancient light with modern measurements. So far, the laws appear remarkably stable. But if we ever find evidence of change, it would revolutionize physics and our understanding of reality. Science remains open to surprises, always questioning even its own foundations. Why do these laws matter to us? Their predictability makes civilization possible. Engineers, scientists, and builders rely on them every day. Technology, from bridges to smartphones, works because we understand and trust these rules. The universe's order gives us stability and inspiration, connecting us to something vast and meaningful. Knowing the laws lets us see ourselves as part of a grand cosmic story. Our atoms were forged in stars, bound by the same laws that govern galaxies. By studying the universe, we discover our place within it. We are not separate from the cosmos, but an integral part of its unfolding story. Our quest to understand the universe's laws is ongoing. Each discovery leads to deeper questions about why these laws exist and why they allow life. We haven't united the laws of the very large and the very small, nor solved the mysteries of dark matter and dark energy. These challenges invite future generations to explore further. The universe rewards curiosity with wonder and insight. This journey belongs to all of us, beginning with a simple sense of wonder. Stay curious, keep asking questions, and join the adventure of discovery. The story of the cosmos is our story, one of endless exploration and awe.